I would venture to say that's why pi is important, although just the fact of the geometry of the circle would probably make it important. But remember, summation of 1 over n squared is pi squared over 6. That has nothing to do with circles. Or if I add up a lot of independent random variables, I get a histogram that, if I smooth it into a density, is 1 over square root of 2 pi e to the minus x squared over 2. In other words, the central limit theorem. And there, pi comes, again, out of the woodwork. Nothing to do with the circle. All right, a digression. One of the cleverest ways to calculate this involves going to the circle. Did you ever read, let's see, Hardy's A Mathematician's Apology? It's not an apology in the new sense. It's a retrospective or point of view or something. He says, if you can't understand Euclid's proof for there being an infinite number of primes, he says, essentially, I pity you. You can't do math. But if you can evaluate this, then you're a mathematician. And you know the trick? How many people know the trick on this one? Yeah, it's a nice one, isn't it? Here, I'll give it to you real quickly. Let's call this S. And now S squared is integral e to the minus x squared, e to the minus y squared, dx dy, which is equal to the integral of e to the minus r squared, r dr d theta. In other words, I've gone from Cartesian to polar coordinates. And now, lo and behold, r e to the minus r squared is a perfect integral. So you can evaluate that, and this integral d theta doesn't have anything to do with r. It gives you the 2 pi. And so the square root of that, s, then is the desired square root of 2 pi. So, by the way, just remembering this doesn't make you a mathematician. You have to do a new problem. Okay, let us embark on something, I don't know, it's not tedious, it's important because it's precise. I'll define what I mean by an achievable rate for a channel, and allow us to define capacity. So, we have a DMC, and the way we're planning to use it is this way. Well, first of all, this, as before, is the product of these. So the nth extension, xn, yn, p, is well defined. Now let's communicate with this channel. Here's p of yn, given xn. And I'm going to want to send an integer w here, which falls in the set 1 2 through M. Sometimes I will call this set. I will say the whole thing is just W is in 2 to the N R. Well, a lot. Since we use it a lot, why not? Look, W is an integer, 2 to the N R might not even be an integer. So round it to the nearest one. All right? And then one integer inside another? No, what I mean is a set of integers 1 through 2 to the NR. Okay, so that's what I mean by that notation. All right. Now, when I want to send this integer through, all I get to do is send inputs to the channel. For example, for the channel with a cell phone, it's electromagnetic signals, probably power limited and band limited. Another digression. Why is CDMA good? What is CDMA? You know what TDMA is? Time slots. Central base station tells you which time slot you could send in. FDMA, frequency division multiple access. Central base station tells you which frequency slot you can send in. Problem, not all of the time slots are taken. Not all of the frequency slots are taken. It's like in the state of Wyoming, all of the land is owned, but no one lives there. So all of the frequency, all of the spectrum is assigned, but at any particular time, it's under only some of the slots are used. CDMA is code division multiple access, which you can think of as not FDMA or the rotation into TDMA, but sort of all of the time, all of the frequency, with all of your power. And what that means is you inhabit the spectrum like a fog. If I look at any chunk of the spectrum, there's no power there. You're all transmitting. But, yeah, there's little power in any chunk of the spectrum. Or if I look at any given time, there isn't a huge pulse of power as some of the users come on and use their slots. So that's really the advantage. It means that you can utilize, get all the gains of a large bandwidth and a duty cycle of 1 in transmission. And it's just simply a rotation of the problem from frequency to time, where you sort of stop halfway in between. Now, it's not a rotation, no one thinks of it that way, but it keeps the power fixed and so on and so. That's it. What does that have to do with this? I said it was a digression, but now I don't know what I was. It must have had some connection with what we were talking about. All right. I want to send this integer W. So I send xn of W. That is, the waveform I send depends on W, but it's matched to the input of the channel. And then I can't help what yn is. It's a sequence of random looks at the corresponding components of x. And from this, I hope to get W hat of yn. And this will be in 2 to the nr. And my probability of error, I'll define. For each W, there's a probability of error. It's the probability that W hat doesn't equal that W. And then there's a arithmetic average probability of error averaged over W. And that's interesting quantity too. So what a code for this channel just consists of, so an MN code for X, P of Y given X, Y, I guess I usually put the Y over here. It consists of an index set 1 through M, an encoding function xn that maps, let's call this script M, the input set into inputs for the channel, and a decoding function W hat, all right, W hat, which maps output sequences back into M. So in short, once I have the index set here, and once I have this map, I'll designate xm with a dot, and once I have this map, W hat, with a dot, I now know how I'm going to use the channel. Put an integer in, I get an integer guess out. So you can see you get probabilities of error and so on from that. This is a good time for a 2-minute break. During this break, some of you can get your graded exams, which are up here, and homework set 6. There'll be another opportunity at the end of the lecture where you can get your exams. You did well on the exam. Yeah.
Thank you.
Yeah.
I'll see you today in the afternoon.
Yeah. I probably maybe after 3 probably or so. Yeah. Good.
What's the process for if we wanted to get something regraded? Specifically, it told me to write it, but I wrote it right there. So,
Oh.
I don't know.
Cool. X rip. Yeah. I see Gotham.
Okay.
And you know where his office is?
I don't, but if it's online, I could
Yeah, just do that. But he'll be here at the end of class to pick up a number of things.
Okay, so at the end of class.
At the end of class, yeah, set up something where he regrades it.
Okay.
I see you have 2 more points coming there. Right?
Thanks.
Yeah. Okay.